question 2. Now, question 2, factorial just means like n factorial just means n times n minus 1 times n minus 2 times n minus 3 until 1. Okay? So if that's the case, right, for me to find out what is the factorial, I can do a very naive method. Very, very naive. I can literally just go down the list and just try every single number, right? Given 120, I can try literally from like 1 to 2 to 3 to 4 to 5, which give me 1, 2, 6, 24, 120, yeah, and so on, right? I can try that, but this one is very tedious or very slow. So what I shared in the previous class is that you will actually have a test case usually from Yao Liang or like whichever testing they use. They will usually have a test case that's extremely large. So Yao Liang shows you all the previous test cases. We can see from here. So there are some really large numbers over here that's being tested, right? There are some really way larger numbers. So if you are running one by one different factorial and check, right, you're not going to pass those test case. Usually, you can see what is the total number of marks. The total number of marks out of here is supposed to be out of 4. So if you don't pass those big test cases, you lose a 0.5 here, you lose another 1 mark here, you lose 1.5 mark. So you actually only get 2.5 marks for writing a brute force solution, but you do get marks. So if you can't find the better solutions, try this first, okay? So to do that solution, you really just need to do a for loop from 1 to whatever infinitely long that number is, and then just find that whether it matches. And once that factorial exceeds the answer, like the answer variable, then after that, forget it. Like we don't find it. Now there are 2 methods that you can actually make this a bit more efficient. The method that is suggested by Yao Liang in his solution is actually to do division. Now what that means is given a number, you divide from 1, divide by 2, divide by 3, divide by 4, and divide 1 by 1 until you reach the end. And then after that, like when you reach 1, we count that as like finished, and then that's actually your answer. So you just keep dividing. Since factorial is multiply, you get the answer already, right? Then you divide back. But our method here sucks, because then we realize that if the answer is 1, 2, 1, this actually somehow work, right? Then it will reach 1. Then 1, 2, 1 is not a factorial. So we actually need to add one extra check. We need to check firstly whether they are divisible. So we do a modulo, and then we check, right? 1, 2, 1 modulo 1 is 1, 2, 1. Is 0. So yes, you can divide. But 1, 2, 1 modulo 2 is not equal to 1. It's not equal to 0, so it actually cannot divide. So we'll just return -1 from here. Okay? So that's to do by division. So you will then see that other kind of numbers all kind of work out. Alright? So we'll try to do that. And what we really need to do over here is we just need to store 2 variables. The first variable is gonna call current factorial. Or product. Let's call it product. Okay. Now then after that, I'm gonna have in n over here. The n is going to be the factorial that I'm trying to iterate through. So I'm gonna start off with 1. Alright. And the condition I want to check is that whether it is less than, right? The product is less than. So if the product is less than the answer, then I want to keep going on to keep multiplying or keep dividing it basically. Oh wait. My bad. We are doing the division one. Okay. Now answer. Division 1. Oh yeah. My bad. So I'm just gonna check whether answer is more than 1. Okay, and whether answer is divisible by n. Okay, so it has to be more than 1, of course, right? Because if in case the answer is actually 0, then if the user pass in a 0, then this should not work lah. So we check whether it's more than 1, and we check whether it's divisible by n. So if it is, I'm gonna do n++, right? Since it passed, right? But it's still more than 1, so I should try to divide. And then after that, I should just do answer divide equal n. Right? So I divide by it and then go into another loop. So once I exit the loop, right? Once I exit the loop, it can be either one of two numbers. It could potentially be a 1, could potentially be a 0. But it shouldn't be a 0 because you do the modulo check already. But if you want just check for sanity, you can. If answer is equal to 1, then you can then you can just say return n, else you return -1. You don't really need to check that, but somehow the answer sheet check that, so you check that, but you don't need. Now I don't like this answer. I'll give you another answer, which I think is much easier to write, or much easier for me to understand. Now what I like to do is, I like to do, still we have to get a n, right? So what I do is, I do this. I store the current factorial and n. Now in my while loop, I check whether current factorial is less than answer, meaning that I'm still kind of less than it, right? And what I do is, if it's less than the answer, I do n++, and then I do answer, current factorial multiply equal n. Right? So I multiply instead of divide. And what this multiplication do is I constantly increase the number, right? So I from 1 times 2 times 3 times 4 times 5 until to the point that when current factorial is either equal to or less than. Then over here I will check if answer, if current factorial is equal to answer, I return n, else I return -1. This is multiplication method. This is division method. Both is really the same. You choose which one you like more.